everybody, it's Mrs. Pound, and we are starting a new chapter, chapter 32 on electrostatics. So this will start our study of electricity, and we will be covering quite a few chapters with electricity. Our objectives for today's video are to describe electrical forces between objects and to explain from the point of view of electron transfer how an object becomes positively charged or negatively charged and relate this to the net charge. So let's first start with section 321 on electrical forces and charges. So first, let's start with a definition of electrostatics. What is electrostatics? This is electricity at rest. So that's the static part. The static part means at rest. And it involves electrical charges, the forces between them, and their behavior in materials. Electrical forces are billions of times stronger than gravity. And you might say, well, gravity is holding us down. It seems like gravity would be a lot stronger. Well, electrical charges are stronger because you can see their interaction. For example, if you were to rub a balloon against your head and then put it on a wall, it will stick to the wall. The electrical forces holding it to the wall are much stronger than gravity. If gravity was stronger, then they would fall to the earth. And actually, they are billion times stronger, but the reason that these forces don't crush you is because they both attract and repel. Not only are you being attracted, but you're also being repelled, which it all balances out so that you're not crushed by these forces. And it depends on charge, and these arise from particles in atoms. Now, charge is a fundamental electrical property. It's like charges repel, and unlike charges attract. Let's take a look at the charges that are in an atom. First, the three particles that are in an atom are electrons, protons, and neutrons. Electrons have a negative charge, protons have a positive charge, and neutrons have no charge at all. And the particles in the nucleus of an atom are protons and neutrons. And here we have a diagram of an atom. So we have the protons, which are positive, the neutrons, which have no charge. So the nucleus of an atom is positive, and then around the nucleus there are electrons, and they are negative. And notice here, this is a helium atom. Two protons, so two positive charges, are balanced out by two negative charges from the electrons, and so that makes this whole atom neutral. And if we take a look at a hydrogen atom has one proton and one electron. So a positive one charge and a negative one charge is zero. That makes a neutral atom. So atoms are neutral as long as the numbers of protons and electrons are the same. So let's take a look at section 322 on conservation of charge. Conservation of charge means that electrons are neither created nor destroyed, only transferred from one material to another in whole numbers. We cannot transfer half of an electron. We can't do that. It has to be whole numbers. And we're going to take a look at what an ion is. It is a charged atom. So we can have positive ions, and a positive ion has a net positive charge because it has lost one or more electrons. So here I have a diagram. Go ahead and draw this diagram into your notes. I have one proton, one electron. If that electron leaves, we're left with one proton. So this atom over here has a net charge of 0. This ion, which has lost an electron, has a net charge of positive 1. You can also have a negative ion, where the net charge on the ion is negative. And this is from the gain of one or more electrons. So hydrogen can also gain an electron. And if here's our neutral, our net charge is 0. If it gains an electron, It now has a -2 charge and a +1 charge. Well, a +1 charge plus a -2 charge is -1. And so the overall charge on this ion is -1. It is a negative ion. And the net charge on a non-ionized atom, as we can see, is 0 because the number of protons equals the number of electrons. So our first objective was to describe electrical forces between objects. We have our positive and negative charges, and explain from the point of view of electron transfer how an object becomes positively charged or negatively charged, and relate this to the net charge. So we're going to be building upon this information more in the rest of the chapter. You probably found most of this to be a review, but we will be adding to this. So don't forget your 5 questions. And if you are listening to this, go ahead and write the symbol for your favorite atom next to your name.